Dear students, today we're going to have another video lecture, and this time it's all about vectors. I know that we have already some facts and information about vectors when we discussed physical quantities because we already established the fact that physical quantities can either be a vector or a scalar. So today we're just going to dig deeper and discuss more, expound everything that you have just learned from the previous lesson about physical quantities. As an overview, here's the outline of this lesson. We're going to discuss vector versus scalar, components of vectors, and vector. At the end of this lesson, here are the things that you should have. You have to differentiate vector from scalar quantities, perform addition of vectors, and lastly, rewrite a vector in component form. Again, let's just recall the differences between vectors and scalars. Basically, when we say vector, a quantity that is fully described by both magnitude and direction. Okay, from this point, when we say magnitude, it is the numerical value together with the unit. Okay, here are some examples of vector quantities: displacement, velocity, acceleration, momentum, and the Earth's pull on your body, aka the weight, and force. On the other hand, scalar quantity is a quantity that is fully described by its magnitude. Again, when we say magnitude, that's the numerical value and the unit. Okay, so the major difference between them is that the vector has direction while scalar quantity only has magnitude. Now, here are some examples of scalar quantities. We have length, time, distance, air, speed, temperature, energy, power, and mass. And here's an additional information. There are times that a scalar quantity has an equivalent vector quantity, meaning there are vector quantities wherein magnitude, when you're not going to mention the direction, it's quantity. What are those? Although we will discuss this later on, I'm just going to give you an example. For example, the scalar quantity distance has the equivalent of vector quantity displacement, meaning displacement is just distance together with direction. So the magnitude of displacement is equivalent to distance. Another one, the scalar quantity speed is equivalent to the vector quantity velocity, meaning velocity is just speed with direction. So the magnitude of the vector quantity velocity is actually the speed. More of that as we move on to our lessons in physics. Okay, so since the focus of our lesson for today is vector. We're going to discuss how vectors are represented. The first way of representing vector is this. Using a scaled vector diagram, or in short, vector diagram. Now, what is a vector diagram? A vector diagram is a depiction of a vector as an arrow that is drawn to scale in a specific direction. When we say scale, there is a measurement that is smaller but it is equivalent to another measurement in real life. Just like for example in a map. Let's say that the map has a scale of 1 centimeter is equal to 10 kilometers. Meaning, if you're going to use your ruler, which is small and has centimeters in it, if you were able to measure 1 centimeter from one place to another, it means that in real life you have to travel 10 kilometers. Okay, so the same goes with vector. For example, every 1 centimeter is equal to 1 kilometer. So if you're going to draw or to measure the vector, that should be your scale. You should convert it into its real measurement. Kasi we can't draw naman kilometers on a paper, di ba? Because that's very long, right? So we use a scale for that so that it would be smaller and more more visualization for us. Now, since vector is represented by an arrow, it means that a vector also has a tail and a head. The tail is the starting point or the origin. That's our zero mark, that's where you start measuring. And then the tip of the head will be the end point or the uh, uh, part where you will get the total magnitude, no? So, kung gaano kahaba yung arrow, ganun kalakas or that's the magnitude of your vector. Here are the characteristics of appropriately drawn vector diagram. Number one, a scale is clearly listed. So in this case, our scale will be 1 centimeter is equal to 4 meters. And then number two, a vector arrow with arrowhead is drawn in a specified direction, just like the arrow shown here. There is a specific direction where the arrowhead is pointing. Diba? Okay, and then lastly, we have the magnitude and direction of vector is clearly labeled. As you can see, it is labeled here. The magnitude is the d is equal to 20 meters. And then the direction is also indicated by the angle, which is 30 degrees. So aside from the vector diagramming, vectors can also be represented as the way physical quantities are represented. Vectors can be represented by either English or Greek alphabet letters kasi nga it is not practical to write the full name of the quantity in an equation. So we should use symbols. It's either Greek or English alphabet. Now, how do we distinguish the scalar from the vector in an equation? So there are several ways, but as a convention for this subject, everything that is in boldface, those are vector quantities. Yung mga naka-ordinary face, those are um, the scalar quantities. So here are some examples, no? Ayan. So we have here the A, that is in boldface, that's vector A. And then also we have the Greek letter tau, lowercase, that is a representation of the vector quantity torque. So in some books, you will see that the vector is a letter with an arrow on top or half an arrow. So it's just the same. It depends on the book. It could be boldface, just like our convention, or it could be a letter with an arrow on top, or a letter with a half arrow on top. So all of those are just representations, various ways of representing vectors as symbols. Okay, thank you for listening to the introductory lesson about vectors. Next time, we're going to discuss naman the direction of vectors. Kasi nga, the major characteristic of vector that differentiates it from scalar is its direction. Okay, so see you in the next video. Thank you for listening again.